Hello friends, today we discuss about what is the kinematics in dimension. So first we define here some definitions. So first is the velocity. We know that velocity can be written by the formula v is equal to ds upon dt. Here ds is the displacement in time dt. We know that the velocity of a moving particle is ds upon dt, where ds is the displacement in time dt. Now we define acceleration. We know that acceleration is acceleration of a moving particle is defined as the rate of change of velocity in time. We know that this is the definition of acceleration. Acceleration of a moving particle is defined as the rate of change of velocity in time t. Let us suppose that if v be the velocity at time t at point P, and v plus del v be the velocity at time t plus del t at point Q. Suppose that when a moving particle is at the point P at time t, so velocity of particle is v. After del t time, when the particle goes at the point Q, so the velocity is v plus del v. Now we find here change in velocity in time del t. So this is v plus del v minus v, so this is equal to del v. As we suppose that a moving particle at time t is at the point P, and at the point P the velocity of the particle is v. After del t time, particle goes at the point Q, and the velocity is v plus del v at the point Q. So the change of velocity in time del t is equal to final velocity minus initial velocity. So the velocity at Q point minus velocity at the P point. Here the velocity at Q point is v plus del v, and the velocity at the point P is v here. So this v is cancelled out. So this is del v. Del v is the change of velocity in time del t. Now we find here average velocity in time del t. In time del t, average velocity in time del t is equal to limit del t tends to 0 and change in velocity in time del t divided by del t. Here this is the average velocity in time del t is given by limit del t tends to 0, change in velocity in time del t divided by del t. And we know that change in velocity in time del t, this is equal to del v. So here we write del v upon del t. So this can be written as dv upon dt. When we take limit of del v upon del t, when del t goes to 0, so it becomes dv upon dt. So this is the acceleration because dv upon dt, this is the rate of change of velocity. dv upon dt, this is the rate of change of velocity, and we know that rate of change of velocity is the acceleration. So here acceleration is defined by the symbol f. So f is equal to dv upon dt. Now this can be also written as f is equal to d by dt and v is equal to ds upon dt. Now we differentiate. We know that here v is the velocity and velocity is equal to ds upon dt. So we put value of v, we get d by dt of ds upon dt. Now we differentiate this ds upon dt with respect to the time. So we get here d2s by dt2. So f is equal to d2s by dt2. This is the acceleration. When we differentiate displacement 2 times with respect to time, we get the acceleration. Now we write this formula, f is equal to dv upon dt. Now we multiply in this by ds in the numerator and denominator. We know that expression f is equal to dv upon dt. Now we multiply in the numerator and denominator by ds. So this can be written as ds upon dt multiplied by dv upon ds. And we know that this ds upon dt, this is equal to v. So f is equal to v dv upon ds. So the acceleration can be written by the three formulae. F is equal to dv upon dt, f is equal to d2s by dt2, and f is equal to v dv upon ds. Now we define some other definitions here. So now we define here some more definitions. Now we define some more definitions. First is what is the radial velocity? Radial velocity. We know that velocity along the radius vector is called the radial velocity. Velocity along the radius vector is called the radial velocity. Here we know that this is the definition of radial velocity. Radial velocity is that velocity which is along the radius vector. That means velocity component along the radius vector is called the radial velocity. Similarly, here we know that transverse velocity. What is the transverse velocity? So velocity perpendicular to the radius vector is called transverse velocity. We know that the transverse velocity is the velocity component which is perpendicular to the radius vector